Hello, this is Dr. Mears. Today we're going to be doing function notation, reading tables, and some evaluation. These are our 3 inserts for our ISN notebook that I'm going to go through. So if you weren't here or didn't understand when we were going over it, this is the time to go over it with me again, and hopefully it'll help. So here we go. We have function notation, reading tables, input, output. The f of x, the x is the input side, so if we were looking at this table, this is going to be the input side, and then that's going to equal the output side, and this is going to be the output side. So if I say I need an input of 13, or f of 13, that would equal an output of 0. Let's look at some more examples. Here we have if x is 15, find f of x. So we have f is 15, so we have to go to where it says 15 underneath the x, and we see that it's going to equal 1 right here, which is f of x. And that's what the directions say down here. It says look up 15 on the x input side, find the value of f of x, the output side. And this is how to write the mathematical sentence. You write an f with parentheses 15, this is f of 15 equals 1. Going the other way, if we're given a output, which is 0, if f of x equals 0, we need to find the input, which is the x. So we go up here, we're given the output of 0, we have to go backwards, we have to find the input, which is 13. So zooming down again, we see, look up on f of x, the output side, find the value of x, the input side, so x is 13. Here's our mathematical sentence, f of 13 equals 0. Let's do some examples. The first example, if x is 17, find f of x, then write a mathematical sentence. So we need to find f of x, so x is 17, so we have to go to the table and look to see where 17 is. Here's 17, and the corresponding output is 2. So in my answer down here, I would write f of x equals 2, but we want a mathematical sentence, so how we'd write that is f of 17 equals 2. And this is the mathematical sentence that I am going to want. And the last one, if f of x equals -1, find x. So I'm given the output side, I need to find the input side. So I'm going to go over here. So I'm looking up to find -1. I find that -1 on the output side is here. So the corresponding input is 10. So down here, x equals 10. However, it says write in a mathematical sentence. So f of 10 equals -1. There's my mathematical sentence, and that's how you do function notation and reading tables. Next is going to be function notation and evaluation. Now, we did this in class, and here's what we wrote in. I'm not going to read it. You can pause it to read through it. If you weren't here in class, you can put in the missing words because we went through and filled in the missing words in class. So you may pause this video here if you need to fill it in. If not, we're going to be going down here. These examples we also did in class, and I'm going to do with you now again, so if you did not understand them, you can review. However, this space is kind of small for the camera, so I took the liberty of rewriting them over. So here we have example 1. Example 1 is right from this sheet here. Example 1 is this example on this side here. Example 1 says f of x equals 3x. Find the following. The first one that you have to find is f of 4. And so what I'm going to do is I'm going to match up the function. This is the f function, and this is the f function that they give us. So I'm going to write underneath f of 4, I'm going to write the f function that they give us. f of x equals 3x. And what they want us to do here is they want us to input 4 for the x. So anywhere we see an x, we're going to input 4 because that's the input they give you. So 3 times 4, that's what we're going to input is the 4 where we see the x. This side where we have f of 4 stays. This side is we evaluate which equals 12. So our mathematical sentence, just like we did, f of 4 equals 12. So if we input 4 in for x, we get an output of 12. Let's try another one down here, f of 2. Again, the function that I'm doing is f of x equals 3x. It wants us to put in a negative 2. Sorry, it was f of negative 2. So f of negative 2 equals 3 times negative 2. Again, this side just stays. It tells us what we're inputting. This side gets evaluated. 3 times negative 2 is negative 6. Here's my mathematical sentence. F of negative 2 equals negative 6. And the last one for the f function. So here we have f of x equals 3x. They want us to input 6. So it's going to be f of 6 equals 3 times 6. Our side of f of 6 stays. This one gets evaluated. It's 18. So that's your example 1. Now on to example 2. Example 2, they give us a different function. They give us a g function. And so this one says g of t equals t plus 5. The first one they want us to find is g of negative 8. So notice g. I know I'm using this function because that is its name. So I'm going to write the function underneath. G of t equals t plus 5. And where I see a t, I need to input negative 8. So g of negative 8 equals negative 8 plus 5. We do nothing with this side. This side just says I'm inputting negative 8 into the g function. This side we evaluate. Negative 8 plus 5 is negative 3. Here's my mathematical sentence. G of negative 8 equals negative 3. The next one, g of 0. Again, we're using the same function. G of t equals t plus 5. We're going to input 0 where the t is because that's what g of 0 means. So g of 0 equals 0 plus 5. This side stays, g of 0. This side gets evaluated, 0 plus 5 is 5. Here's my mathematical sentence. And the last one for this function, g of t equals t plus 5. I need to input my 7 where I see my t. So g of 7 equals 7 plus 5. G of 7 equals 7 plus 5 is 12. So notice this side stays, this side gets evaluated. Here's my mathematical sentence, G of 7 equals 12. If this is going a little too fast for you, then I say you can pause it, slow it down, so that you can rewind, review, and redo if necessary. If not, let's go on to example number 3. We see we have h. h of n equals 2n minus 4. So we still have an input, n, and we're still going to be finding what our outputs are. So here's h of 1. So h of negative 1. So h of n equals 2n minus 4. They want us to input a negative 1, so h of negative 1 equals 2 times negative 1 minus 4. This side stays, h of negative 1. This side gets evaluated, and we have to use PEMDAS with this. So we have to do order of operations. So first we're going to multiply, because in order of operations we multiply before we subtract. So 2 times negative 1 is negative 2. I bring down my minus 4. I'm not done yet, because I still have to do my negative 2 minus 4, which is negative 6. I'm down to my mathematical sentence, h of negative 1 equals negative 6. Let's try h of 3. Here's my function, h of n equals 2n minus 4. I want to put 3 in, that's where it says, put 3 in for my n. So 2 times 3 minus 4. Again, I have to use PEMDAS. H of 3 equals multiplication first, 6, bring down your minus 4. So h of 3 is going to equal 2. There's my mathematical sentence. And the last one, h of 9. H of n equals 2n minus 4. Where I see an n, I'm going to put a 9 equals 2 times 9 minus 4. PEMDAS, h of 9 equals 18 minus 4. And so our last step, h of 9 equals 14. And there's my mathematical sentence. So we're at 10 minutes. I have one more thing to do, and that's using function notation to go the other way, which is to solve for the input. So here we see this is the insert, using function notation to solve for the input. We have steps: write the function, replace f of x with the output number, and then solve for action showing work. So we're going backwards. So they actually give us the answer here. So here's the function for example 1, f of x equals 4x plus 1. They want us to find the x. They give us the answer, the output of 25. So here's what you do. You physically take out the entire f of x. That's out of there. You have to replace it with our 25. So I'm going to rewrite this over. F of x equals 4x plus 1. I am physically going to take out the f, the parentheses, the x. That whole thing is going to come out. In its place, I'm going to write down the number 25. I have an equation now. I need to solve it. I need to remember my rules for solving, which are my inverses. Inverse, undo the 1, subtract it out. 24 equals 4x. Undo the 4, divide it out. X is going to equal 24 divided by 4, which is 6. That's my answer. In a mathematical sentence, that would be f of 6 equals 25. It did not ask us for a mathematical sentence. That's what it would be. It just asked us for x, which is 6. Try to write a little bit smaller. Here we have g of x equals negative 2x for example number 2. Here's our function. Find x if g of x equals 30. So I am going to take my entire g, my parentheses, my x out. Replace it with the number 30. Now I have 30 equals negative 2x. Inverse operations, divide by negative 2. X equals negative 15. That's what my x is. That's what it asked us to find. So we're going backwards now. And my last one, h of x equals x over 3 minus 1, or x divided by 3 minus 1. Find x if we have x equals 4. Find x if we have x equals 4. So let's take out my h of x, the entire thing. We're going to replace it with the number 4 because that's what they gave us. So I now have 4 equals x divided by 3 plus 1. Let's use some inverse operations. Add 1 to both sides. 5 equals x over 3. This is linked by division, so I have to multiply the 3 by both sides to cancel it, so that I get x by itself. X equals 3 times 5, which is 15, and that's what they wanted me to solve for. I hope this helped. This is Dr. Mears. This is function notation, using tables, evaluating, and solving for the input. Have a good day.